Hi everyone. We are going on to polynomial division today, which technically polynomial division is synthetic division or long division. We're going to look at synthetic division. I'll show you long division at some point. It just doesn't come up as often and it's more challenging. So we'll look at it, but for the most part we're going to be using synthetic. So let's go ahead and get to it. So before we get into synthetic division, just a little bit of why we're doing synthetic, because this does feel kind of a sidestep from what we've been doing, factoring and graphing. But there are some polynomials that are not factorable and they're not quadratic, so we can't use the quadratic formula to find x-intercepts. So we're headed in that direction, but we need synthetic division to do that. So first, a few theorems that are going to tell us what exactly we're finding. So the first one is the remainder theorem, and that tells us if we've got a polynomial, so if polynomial f of x is divided by some factor, we'll call it x minus a, and there's a remainder, then f of a equals that remainder, or vice versa. The remainder equals f of a. So essentially it is the same as plugging in the value a and getting out a y value. If we divide by a linear factor x minus a, it actually tells us what y value we would have gotten. The remainder is the y value that we would have gotten if we plugged it in. It's kind of interesting. Piggybacking off of that, the factor theorem says, even more importantly, if polynomial f of x is divided by a factor x minus a, and the remainder equals 0, then a is an x-intercept. So these go hand in hand, because if we're saying the remainder is f of a, and then here we've got the remainder being 0, well, if f of a equals 0, then it does have to be an x-intercept, because it's going to be the point a0, that's an x-intercept, or a root. And I also know x minus a, this is why it's called the factor theorem, x minus a would have to be a factor if a is an x-intercept. So this is a big deal whenever we're working through these synthetic division. We're going to be learning pretty much just using the synthetic division for today. But going ahead and thinking through, okay, what does it mean that it divided in evenly, or what does it mean that it has a remainder? So these first two I don't want you to write down. We're not doing the synthetic division just yet. I don't want you to write this down. Just thinking through with that remainder theorem and factor theorem, if I divided by x plus 2, so we'll talk about the actual nuances of dividing later, but if I end up with this remainder of -9, what the remainder theorem says is that I would know that f of -2, so it's the opposite sign, equals -9. So that would be the same as if I plugged in -2 and got out -9. Now, I don't know that that would be any faster synthetic division than plugging it in, but it does give us that information, which is mostly important whenever I divide and I end up with a remainder of 0, because that tells me that my f of -3 equals 0, which means that -3 is an x-intercept. It also means that this x plus 3 is a factor of that whole polynomial, which would be super helpful if I was trying to get it in factored form to solve or graph or all sorts of things. Okay, so that's what we're getting from things whenever we use division, synthetic division or long division. Either way, we're ending up with f of whatever the opposite sign of that is. f of -2 in this case. So go ahead and write down our first example, what we're going to be dividing by. You can pause the video at any time if you're needing to, but I'm going to go ahead and jump right in. So with synthetic division, we are always setting up synthetic division where we've got this number in a box, and it is always going to be, if this was a factor, the x-intercept that would go with that factor. So we could set it equal to 0 and solve. A lot of what we're going to be dealing with is linear, so it is going to be the opposite of the sign. But if you did have like a 3x plus 2, you could set it equal to 0 technically and subtract and have -2/3 in the box. So that's what goes here. Along the top, we're putting in all of the coefficients of what we're dividing into. So I've got 4, 8, -9, and -18. I do want to make sure that I have a place for every power. So I've got an x to the third, an x to the second, an x to the first, and an x to the 0. If I'm missing one of those, so say like I didn't have an x squared, then I would want a 0 in its place. So whatever your power is there, I need everything below that. So that's our setup, and now we are ready to start. So synthetic division starts by dropping the first coefficient, or the first number. Then we'll multiply by what's in the box. And now we've just got this pattern of combining, multiplying by what's in the box, combining, multiplying by what's in the box, combining, until we're done. So we got 0. So first of all, that tells us that x plus 2 is a factor divided in evenly, that -2 is an x-intercept. All of that will be important eventually. But whenever we divided, what we got out of it is this part. So that part's the remainder, that last number. But this part, if I'm putting it back into a polynomial form, I am going to be knocking it down a power because I've divided an x cubed by an x to the first. So it is going to go down a power every time. So I've got a 4x squared, and then each other number is the next coefficient. So technically a 0, x to the first, not necessary that I write that, but so that we can see how that's working, and then minus a 9, and that will be a constant because I had x squared, x to the first, and then x to the 0. And then of course I would not really want that 0x there, it's kind of weird, so a 4x squared minus 9 would be the result when I divide this polynomial by this one. If I'm working on putting it in factored form, then I could go ahead and say that this is one of the factors, and then the other factor is one that I found. But today we're focusing on that part. So if that's confusing you, don't be confused. That is what we got when we divided. Let's try another one. So see if you can set this one up on your own. Pause it, set it up. Okay, so we've got a -3 in the box. Since we're dividing by an x plus 3, I've got a 1 for my x to the 5th, x to the 4th. I don't have an x to the 3rd, so I need a 0. I don't have an x squared, so I need a 0. And then I've got a -10 and a 20. So there's my setup. If you paused it and tried the setup, but then you didn't go further, now check your setup or have the correct setup. See if you can use the synthetic division from there. Okay, we're dropping the first number, multiplying by what's in the box, combine, multiply by what's in the box, combine, multiply by what's in the box, combine. Oh, I've got some big numbers. Multiplying by what's in the box. Let's see, we got 54, -54. Some large ins. Combining, multiplying by what's in the box. Let's see, we've got 12, and 6 times 3, 18, 192. Oh, nope, it's positive. And then combining them. Oh, y'all, it's gonna hurt my brain. And let's see, 102, 112. 212 is what I meant. Whew, okay, that was a little rough. So we know it did not divide evenly, and it is really nice when it does because your numbers do end up being nice at the end. They're combining to be 0, so that's always handy. But we still have divided, and we've got an answer for our division problem that we've gone down a power. So we've got an x to the fourth plus 2x to the third minus 6x squared minus 18x minus 64. Now sometimes, for me, I'm really fine with you just saying the remainder is 212. There are areas where, just like in grade school when you would divide, you would go ahead and put your 212 over what you divided by. So you could also have all of this and then technically plus a 212 over x plus 3, what you divided by. Okay. And the last one, see if you can set up and divide here. Whoa, cover it. Okay, pause, work it out, because I'm about to reveal it. So our setup, noticing that it is missing an x to the fifth and an x to the first, and an x to the third. We've got 3 zeros in here for placeholders for those. You should have a 3 in the box, and then going through that process of bringing it down and then multiplying by what's in the box. Combining, multiplying by what's in the box. You end up with quite a few zeros in here. We went down a power, so we've got a 2x to the fifth plus 6x to the fourth. We don't have a third, we don't have a second. This would be our first, so 1x. And then 3 is the constant, and 0 is the remainder. So we did have x minus 3 is a factor. 3 would be an x-intercept, and whenever we divide, we get this lovely quintic polynomial. So if you're needing more examples, there are definitely other videos out there on YouTube, but also with the Delta Math, it will give you the solution if you miss it. So look at more solutions if you need to, and have a great day.